We are going to look at adding and subtracting radicals and what we can do to combine like terms of like radicals. So it's kind of similar to, let's go back to some basic algebra, 3x plus 4x. If we look back at that, we know that this combines to 7x because 3x's are really just saying like I have an x, and another x, so altogether I have 3 of them. And with 4x, that means I have x plus x plus x plus x, 4 of them, so altogether I have 7 of them. So it's very similar when we have like radicals, just like here I had like variables. If I have 3 root 2 plus 4 root 2, the thing that is in common is square root of 2. So I can combine these by adding the coefficients, which they're not technically coefficients, but we can think of them as coefficients. The 3 and the 4 combine to be 7 square root 2. So we keep that as the square root of 2. Okay, so we can combine like radicals by adding or subtracting their coefficients. I'll write that out. Combine like radicals by adding or subtracting their, I'm going to put coefficients in quotations because it's not technically coefficients, but we can think of it that way. So we need to have the exact same radical though. So let's start with another example. So if I have square root of 5 plus 2 cube root 5 minus 4 square root 5 minus 2 cube root 5. So right here, there are radicals that all have 5 underneath the radical, but there's some square roots and there's some cube roots. So we cannot combine radicals unless they have the same root. So I'm going to reorganize right here a second. So I'm going to put the square root of 5 minus square root of 4 root 5 closer together, and then put the cube root ones plus 2 cube root 5 minus 2 cube root 5. So the square root 5 minus 4 square root 5 can be put together because they're both square root of 5. I'm going to put a 1 in front to emphasize that square root 5 is, there's 1 of them. So just like x is 1x, coefficient is 1. So 1 minus 4 is negative 3, and then keep the common square root 5. Now the next one, 2 minus 2, when I combine these cube roots, 2 minus 2 is 0, 0 cube root 5. So 0, if 0 is a coefficient, it's actually going to be just completely gone. So that can happen. So my answer is negative 3 square root 5. Now for my next one, I have square root 50 plus 5 square root 18. So right now, I cannot combine these. So I'm looking at this and they're not like radicals. I have 50 under one square root and I have 18 under the other square root, so I cannot combine them. But if we look at those numbers, we should be kind of thinking about how maybe I can simplify. So 50 breaks down to 25 times 2, and I can pull out the 25. Square root of 25 is 5, so 5 square root 2. Now the next one, let me bring down the plus 5. I'm going to replace 18 with the perfect square that is a factor of 18, 9 times 2. Square root of 9 is 3. So remember now here, the 5 and the 3, those get multiplied. So 15 square root 2. So now that they're simplified as much as they can. Now I do have like terms, so I can combine these. 15 plus 5 is 20. So combine to 20 square root 2. Let's do one with x's. Square root 72x cubed minus 3x square root 32x. Again, right now, they're not the same radical, so I cannot do anything to combine. It's only if they're the exact same thing under the radical. But let's break down 72. Right away, I'm thinking 9 times 8. But 9 has a perfect square, but also 8 has 4 in it. So I'm thinking there's something higher. So because if I break down 9, break down 8 to 4 times 2, and then really think about this, that I could break 72 down to 36 times 2. So I was looking for that highest perfect square. And you could do that differently, break it down to 9 times 4 times 2, but I'm going to show it as my largest perfect square. X cubed, I'm going to break that down to x squared times x. So 36 comes out as a 6. Square root of x squared, that comes out as an x. So I have 6x square root 2x stays inside. Now if I look at 32, I'm going to break this down to, again, trying to find the largest perfect square, which is going to be 16. So if you think 4 times 8, but then 8 still has a 4 in it, so the highest perfect square would be 16. 16 times 2. So square root of 16 is 4. 3x times 4 is 12x. And then I have 2x on the inside still. So now my radicals are exactly the same. And you can kind of look at this a couple different ways. If you look at the radicals as the same, and then do 6x minus 12x, 6x minus 12x is minus 6x, keep the 2x. Otherwise, you can really look at it also as x square root 2x, x square root 2x, kind of like the variable part. Those are the same, but you'll still get the same answer because then you would do 6 minus 12 is negative 6. So either way, my final answer would be negative 6x square root 2x. Last, let's do a cube root. Cube root of 8y to the 5th plus cube root of 27y to the 5th plus y cube root of y squared. So right now, none of the radicals are completely matched up. None of them are exactly the same. So I probably will have to do some simplifying first. They are all cube roots, so that's good. So let's break these down. So now we're not looking for perfect squares, but perfect cubes. So 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Those are the numbers I'm looking for. So cube root of 8 I can just leave, but I want to break y to the 5th down to a power that's a multiple of 3. So it'd be y cubed, and then I'd still have y squared left. Next one, 27 is also on my list. So that I'm just going to leave as 27, and again, break down y to the 5th as y cubed, y squared. And then the last one, nothing I can do. I can't pull y squared out of a cube root because I don't have at least 3. So now, cube root of 8 is 2. Cube root of y cubed is y. So 2y cube root of y squared. Plus, cube root of 27 is 3. Cube root of y cubed is y. So 3y cube root of y squared. And then again, I'm going to bring down the last part. So now I'm going to combine like terms because all of these are cube root of y squared, so they have a common radical. And then my things in front, and again, I could look at it two different ways, but if I combine my coefficients, 2y plus 3y is 5y, plus y is 6y. So that is my final answer.